In this video, we're going to practice solving square root equations that have unlike terms. And our equations are going to come in three different flavors. We might have one square root term, and we've already covered this situation with the two-column table. But the two-column table is only effective when we have a single variable term or factor. In this video, we're going to practice solving equations where we have two square roots. These are unlike terms, and so we can't use a two-column table directly. And in the next video, we'll look at situations where we have a first-degree term along with a square root term. Now, the strategy for both of these will be to square at some point in the process, and please keep in mind that whenever you square both expressions, you should always check your answers because squaring can introduce extraneous solution. For example, if we start with this equation, we can see it has a single solution, and that's positive 2. But if we square both sides and simplify, our new equation has two solutions, negative 2 and positive 2. Our new solution set does contain our original, but also contains a second solution, which, if we substituted in the original, we would get negative 2 equals positive 2, which is false. So whenever you square both expressions as part of your solution process, please make sure you always check your solutions. So I'll do this first one. Step 1, I need to have my square root expressions on both sides of the equal sign. Then I square both expressions and simplify. Now I'm left with a linear equation. I can subtract 2k from both sides, and then I can add 12 to both sides, and I'll get that k is 8. Last, I'll check to make sure that going back to the original and substituting 8 does lead to expressions that are the same, and that verifies for me that this is my solution. Here's one for you to try. Please make sure that you begin by getting one of your root terms on either side of the equality symbol. Step 1, I would add the square root of k plus 18 to both sides and simplify. Now I would square both sides and simplify. We can subtract k and get 2k. We can subtract 14 and get 4. And then we can divide by 2. And we can check our solution. How about this one? This factor of 4 is new, but we can still just square both sides, and we'll use the power of a product property over on the left. If I square 4, I'll get 16. If I square my square root, I'll get n plus 1. And please make sure to include parentheses, because this factor is multiplying both of these. So when you square both factors, make sure you have parentheses here. And of course, when I square the square root, I'll get this sum. Now I'll distribute. Subtract 11n from both to get 5n. Subtract 16 from both to get 20. Divide by 5. And check my work. And here's our last one. After adding the square root of 6x minus 12 to both sides, squaring both sides, and simplifying, I have a quadratic equation. So I'm going to try zero product method. I subtracted 6x and added 12 so that I could be equal to 0. I have some like terms here, so I'm going to have x squared minus 8x plus 12. Using guess and check, I can see that factors to x minus 6 and x minus 2. So my two solutions are 6 and 2. I check 6, looks good. I check 2, it also looks good. So both my values are solutions. Well, that concludes this video where we've begun solving square root equations that have unlike terms.